SEMM3623 Materials Engineering. This is for the session 2022-2021, semester number 2, right? So I'm not sure whether you have class yesterday with other subjects, but yesterday the UTM Smart has not working properly in terms of the attendance. So I'm going to use the Google form today. Let me share the link for your Google form. Okay, you can put your name in the Google form as the attendance. I hope everyone is here. Okay, it seems that some of you guys has just joined the WhatsApp group. So I need to put the training info in the group description. So I'm putting now. Right. Okay. So this link for the class, I'm going to use the same link throughout the semester, regardless what day it is. Just click on this link. Okay. Right. I just changed the group description now. Oh, you maybe you can log in the UTM email. If you got logged in the UTM email, can you fill in the Google form? I have already seen responses, around 20 responses already. So there should be no problem. Why cannot sign in UTM email? Is there any problem with your email? I think you are supposed to be able to sign in. I think you guys already third year, right? So it's not much of a problem. I think you're already used to the system. Yeah, try to work it out somehow to get into your UTM email. Right. So okay. Today is just introductory. The introductory lesson. So we have 1 hour. So I'm going to at first maybe just introduce myself. My name Abdullah Sani. Okay, Abdullah Sani. So I'll be teaching you this semester. So I hope you can communicate with me if there is any problem regarding the study of uh, academic related stuff. Um, you can ask me through the WhatsApp. Yeah, I will try my best to get to you. Sometimes I'm busy, sometimes, but I will eventually. I will reply you back if you have any question. Okay. So, right. So the first thing I'm going to share here is the course information. All right. Okay. So now it's 29. What is the full number of students? Is there anyone who have not joined us? Okay. Anyway, we just proceed. Okay. Right. Course synopsis. All right. So this course is designed to introduce you guys to the concept of fracture mechanics and how engineering materials respond to mechanical loads. Okay, the failure behavior of engineering materials will cover fracture, fatigue, creep, wear, and corrosion. So I'm sure you guys are already exposed to this kind of phenomenon or this kind of uh, performance, materials performance or material testing. So we go a bit deep into this, okay? And the course will also provide students with knowledge of how to conduct failure analysis and determine the root cause of failure under different mechanical loading. So you will also, one of the key point is the failure analysis, okay? You will be also exposed to failure analysis and the mechanical behavior of polymeric materials, ceramic and composites will also be covered as well examples of case studies of selected engineering materials for specific product design. So it's kind of like case study. Yeah? So right. Anyway, these are the course learning outcome. I'm not sure, but I think you should have familiar with all these things. Okay, so if you are taking a course, okay, a subject, right? So there will be what we call a CLO, okay, course learning outcome. So it is basically what you get from that course throughout the semester, right? So these are the items or the CLOs that you will gain throughout this semester. Okay, we have four CLO1 to CLO4 as the main knowledge related, and CLO5 is how you apply it by seeking information through materials such as the internet and stuff. Okay, so CLO1, okay, the first thing or the first outcome or you can get from this course uh, is at the end of the course you will be able to distinguish, okay, the mechanism of metal failures, okay, metal failures, right? And number two, you be able to analyze the metal failure mechanism, okay, and propose the control method, right? And number three, you actually will be able to relate, okay, the various form of corrosion as well as wear with the basic theory of electrochemical corrosion. And finally, compute structure properties processing relationship of non-metallic materials. So this CLO01 to CLO04, okay, will be tested in your final exam, okay, and CLO05 is mostly uh, given as assignment, okay. So the content, okay, of the course, okay, actually covers from CLO 1 to CLO 4, right? So CLO 01, okay, and CLO 02, okay, that will be included as test 1, okay, and for test 2, CLO 3 and 4, okay. So assessment wise, there will be 100 of total marks, right? 40% of the total marks comes from the final examination, right? And 20% from test 1, 20% from test 2, okay? That makes 40% from test, huh? So test 1, test 2, okay, gives you 40%. Okay, and assignment, we have two assignment, okay, 10 each, okay, 10 each. So there will be a total of 100, okay, 40 of test, 20 of assignment, 40 of final exam, okay, total of 100, right? So applicable textbook, you can, Callister, I think you if you take material science, you will be uh, also be using this one, okay, in I think in your second year, right? So pretty much that is what we will go through. Right, so these, okay, CLOs need to be you need to put this in mind, okay. So I will share this course information in the group's WhatsApp group as well. So basically, as a formality, I will also upload in the e-learning, okay. But for for quick communication, okay, I think it's more convenient for you and me to share things in the WhatsApp, okay, because we just grab and just drop there, right? So but I will upload. So the lesson will be recorded, but I will record only the lecture, not all these explanations. So, do you have any question regarding the course itself? All right. Are we clear about this? Okay. So, all right. So you have to attend, yeah, this class. Uh, okay. Otherwise, you cannot sit for the final exam. Okay. I think I will monitor with the Google form. Please respond in the Google form. I think got pretty much all people here already fill up their names. All right. All right. So let's get going to our lecture. Right. Uh, is my voice clear, guys? You can hear it clearly, or there is some
Clear,
maybe
Doctor.
clear?
Crystal clear.
All right, all right, all right. So that's good. Okay, let me share the first chapter. All right, all right. I think you guys are connected to WhatsApp already. So I just quickly going to prop this into the WhatsApp so that it's easier. Because sometimes we over complicated things, want to use e-learning and then the system crash, want to use the UTM, then cannot scan the barcode, so it's not that practical. So I just put in the WhatsApp. Okay, I will upload it. Okay, just keep this as a schedule, right? And also I'm going to put the CLOs also in WhatsApp. That's the thing that you need to know. Um, Please download this in your WhatsApp. Otherwise, then 2 3 months pass and then heading to test one, then you ask again. Okay, what is the mark distribution? Okay, it's already whatever I share. Please download. Okay, sometimes you don't download and then the WhatsApp it's just you cannot download after the time sometimes pass, so you so I have to send it again, so I hope you can download again. So it's in your phone, so it's already easy for you to look at it. Okay, so yep, these are the important things that I'm sharing right now. Right, this is the all right. Oops. So it's for your information. Okay, this one is the mark distribution. Okay, so test one, test two is CLO 01, CLO 01 and 2 for test one, CLO 03 and 4 for test two. Okay, so actually I'm stressing about all these marks. Of course, the most important thing is what you learn in the course, right? Right. But marks is something that is very realistic, because if you learn all things but your mark is not good enough to pass, then you have to repeat. So to be realistic, you have to look at all these marks and you know be particular about your marks. Okay. All right. Anyway, and I think it is already sufficient for you to refer at what I have shared in the WhatsApp group, okay, regarding the course and the mark distribution and the overview of the course, right? So now, right, I am going to I'm going to share with you the first lesson, okay? So since this is a very beginning of our course, okay, this content is not so heavy, right? All right, I think I also shared with you, okay, those who have not yet get it because you joined the WhatsApp group late. Maybe one of you can just forward it, okay, back in the group, right? So chapter one, okay, metal fracture, okay. Um, the learning outcomes. Okay, just now we have take a look on the course learning outcome. So this is lesson learning outcome, means we break it down. Okay, for this lecture, what we want to learn is we want to understand the principle of fracture. Okay, and number two, we want to be able to describe the process of fracture of metals and differentiate between ductile and brittle fracture, right? All right. Okay. So you see in the picture that is one of the example of the failure, right? So failures is something which is tragic, okay, and catastrophic. Okay, we do not want this kind of failure to occur, right? So as an engineers, okay, or designer of engineering related person, right? We actually try to avoid this by uh, designing in the best way to avoid such stresses or condition, okay, that will cause the failure in terms of design, manufacturing, and material selection. Okay, but okay, failures is something inevitable. So it is something that you cannot avoid. Okay, so what you can do is you can learn from the mistake. Okay, you can learn from the mistake. Okay, okay. So that is why it is important to learn about fractures. Okay, uh, fracture mechanics and failures. Right. So excuse me for a while. I'm going to plug in my power supply. Okay. Right. I'm back. All right. Failure is something inevitable. So, when a metallic body is subjected to a stress, it withstands the applied stress. Okay. When the body is no longer able to withstand the applied stress, it starts cracking. Okay, cracking. So, cracking is the starting point of failure, right? So, materials, okay, they have their own integrity. Okay, how much we can withstand the stress applied on it. Okay, so usually when we design, okay, we always consider the safety factor, for example. Okay, and when we this includes the selection of materials, like I said just now. Okay, with the material selection, we refer to the yield strength, right? To the ultimate tensile strength, okay, to the toughness and stuff, right? So when the stress exceed what it can withstand, okay, eventually there will be cracks, right? So, right, fracture. I'm sorry, I'm in the university. So, okay, fracture. Actually, it made up from two steps. Okay, two steps. First is the crack initiation. Okay, and the second is crack propagation. Okay, so two steps of fracture. Okay, initiation and propagation. Okay, all right. So at first, as you can see, this in this SEM image, okay, or micrograph, right? So when stress is applied, okay, this is the formation of the crack or crack initiation. Okay, and when the crack is initiated, okay, it propagate can propagate. Okay, this is the how it looks like when it propagates, right? It gets bigger and bigger, and eventually there will be fracture. Okay, there will be fracture. So cracks is the beginning of fracture. Okay, initiation of crack and propagation of crack, and finally final result, okay, there will be separation of body, right? So you got one piece of body, okay, into two pieces of body or more. Okay, sometimes it is cracked to some um, three or four, okay, or multiple pieces. Okay, it depends on the materials. Right? So okay, the first idea is the fracture. Okay, involve two steps. Right, that is a crack initiation and crack propagation. Okay. Okay, a majority of component failures is due to fracture, right? And therefore, an understanding of this phenomenon forms an important aspect of failure analysis. So we have to understand the problem. Okay. Um, of course, failure happens, but that is something that we can learn. Okay, we have to learn from the mistakes. Okay. So fracture can be classified broadly as ductile fracture and brittle fractures. So we can categorize the fracture, a type of fracture, as ductile and brittle. Okay, ductile and brittle. So, all right. What is ductile fracture? What is ductile fracture? So you can see in this figure in the right hand side, this is an example when it is when force is was exerted on this piece of a test piece.